Here's problem 1513. A weight of mass m is at rest at O when suspended from a spring as shown. When it is pulled down and released, it oscillates between positions A and B. Which statement about the system consisting of the spring and the mass is correct? Well, let's look at the answers. Let's see, A. The gravitational potential energy of the system is greatest at point A. Point A is the lowest position, and so it cannot be the greatest gravitational potential energy because gravitational potential energy goes as mgh, and if our h is 0, then we're not at the greatest amount. So it can't be A. A is out. B. The elastic potential energy of the system is greatest at O. O is the equilibrium position. It's where the spring is not stretched or compressed. So our x is 0 at that point. And the potential energy, which should be 1/2 kx squared, is actually 0 at that point. So we have no elastic potential energy at O. So that's not true. C. The rate of change of momentum has its greatest magnitude at A and B. The rate of change of momentum is actually force. Force is equal to the change of momentum per time according to Newton's second law in momentum form. So where the force is greatest, we'll have the rate of change of momentum being the greatest as well. And that's going to occur at A and B, where the spring force is at its greatest value away from equilibrium. So that actually is correct. So if I can do that. Let's look at D and E just to be sure. The rate of change of gravitational potential energy is smallest at O. Well, that can't be true because the velocity is greatest at O. That's our maximum speed, and hence the position is changing most rapidly at that point. Hence the rate of change of gravitational potential energy is changing most rapidly at O, not its smallest value. So that is not true. E. The rate of change of gravitational potential energy has its greatest value at A and B. Well, we just determined that it should be at O, because at A and B it momentarily stops. Velocity is 0, and hence the position is not changing very rapidly at that point. Hence the gravitational potential energy is not changing very much. The rate of change is not much at A and B, and hence E is not true either. So we are left only with answer C.